So next we'll see this question. It's a combination of solid category question. Now, a combination of solid basically means that if you have a solid, keep another solid at the top of it, and you need to draw the isometric view or projection of these two solids in the combined view. So you get a sort of a answer like this. So if you have more than one solid stacked one over the top of another, and those kind of questions are come under this category, combination solids. So in this question, it's very simple. A paperweight is made by placing a sphere of 20 mm diameter centrally over a square slab of side 40 mm and thickness 10 mm. Square slab is nothing but a square prism itself. When you call a slab, the thickness is very small. If you take a square prism, okay, if you take a square prism and if you compare the height of the square prism with the side, if this length is very small, something like this is a square slab, okay, or rectangular slab, the thickness is very less when you compare to the this length and breadth. So this kind of solids are called slabs. Okay, so if you have a slab, you have a slab like this. Let's say this is a square slab, and you place a sphere at the center of that slab, and together this slab and the sphere fused together form a paperweight. Okay, a paperweight. So you need to draw the isometric projection and isometric view of the combination of solid. Assume one edge of the square slab is parallel to VP. So you're asked to draw the isometric projection and isometric view. Normal case, normal questions, you won't be asked to draw the isometric projection and the view in the same question. Why I've given you this question is there is a reason for that. When you draw the isometric view of a sphere, and when you draw the isometric projection of a sphere, there is a small difference. So just to point out that difference, what is when you compare isometric projection and isometric view of a sphere, what is the difference that you have to notice? So that is why I have given you this question. The question to draw the isometric projection and isometric view of the same question. So basically we start with drawing the front view and top view. So when you look from the top, you have a square slab just like this. Okay, as you can see, this square slab, one side is parallel to VP. Find out the center to draw the diagonal. Locate the center. When you look from the top, a sphere is seen as a circle. So that's your top view. The front view is the thickness of the slab is 10 mm. Find out the center of the sphere. This is the center of the square slab, the top surface. You take 10 mm, which is the radius of the, just 20 mm diameter, so 10 mm should be the radius. Take 10 mm, locate the center of the sphere. With this as center, you draw the circle to get the front view. So that's the front view and top view. So the idea is to solve this question. It's very simple. You draw the isometric. We'll start with the isometric view. Now, isometric view of this square slab first. Then you locate the center point of that square slab, or the top surface center point. Then you take the radius height vertically above, and then you draw the circle. That's it. It's very simple as that. So you know the thing. We have done this many times. So whatever that is in the top view is a square in the top plane will be seen as this. Now to complete it in a very simple fashion, what I'm going to draw is that I'm going to draw the thickness below like this to complete it very fast. So next I'm going to draw the diagonal to find out the center. From the center, I'm going to take this height. Since the isometric view, you can take the actual dimension, which is 40 mm. Taken this as 40, this is 10. Find out the center. The radius of the sphere is 10. Locate the center of the sphere. Now up to this point, you have followed as usual. There is nothing pretty much difference in this. But when you draw the circle, so the answer is, to complete the answer, you have to draw the circle. Draw the circle. That's your answer. That's exactly what it looks like. And you can rub off this portion. Okay, so that is the isometric view of the combination of solid. You draw the sphere. That's it. Now the question is, what is the radius of this circle? Now if we are drawing an isometric view, the radius of the circle will be 1.22 times the actual radius, which is in this case 10 into, so your answer is 1.22 into 10, which is 12.2. 12.2 should be the radius of this circle, which is 12.2 millimeters. Okay, why is that? To explain that, it's a little bit difficult, but still, how do you draw the isometric view of a sphere? Actually, what you do is you actually divide the sphere into so many circles. Okay, so many circles, and you draw the isometric view of these or each and every circle. So a circle can be, the isometric view of a circle is the ellipse, you know that. So imagine that I have drawn the isometric view for all these circles. I'll get a circle like this. If you measure the radius of this thing, that will be 1.22 times the actual radius. Remember, in an isometric view, there is a small enlargement in the appearance of the object, and that appearance is calculated to be 22% of the actual thing. So that factor is actually coming here. Now the question is, how do you remember this? Okay, in isometric view, I got it. When you draw the circle, you have to draw the circle at a radius of 1.22 times the actual radius. Now, how do you remember this 1.22? It's nothing but the reciprocal of 0.816. 1 divided by 0.816 is 1.22. So you don't need to by heart this. If you forget it, just take 1 divided by 0.816 and you'll get this answer. So just to remind you, the way we have done this, we have drawn the isometric view of the square slab, located the center of the square, and the top surface, taken this radius, because the center of the sphere is not at the surface, at the top. So here also you have to take the isometric view kind of approach, like the actual radius 10 mm. But when you draw the circle only, you take the radius of the circle is different. The radius of the circle is 1.22, right? So that's it. So that's the isometric view. Now, if you draw the isometric projection, the only difference is, if you draw the isometric projection, each time when you take this, you have the isometric, the front view, top view, you have to construct something called an isometric scale first. From one side you take 15 degrees, the other side you take 45 degrees. You construct an isometric scale, and then what? You have to find out the corresponding isometric dimension of each and every this thing. So basically we have taken this 40 mm distance. You take this 40 mm distance, offset it here, and from this point you draw a line which is parallel to the end line. Okay, so this distance will give you the isometric dimension, isometric length corresponding to 40 mm. So you take that distance, offset it here, you complete it. And to take the thickness also, you take the 10 mm distance, offset here, draw a line parallel. So each time you take a dimension to draw here, you have to convert that into isometric length. All right, so it will be a little bit short, slightly smaller than the isometric view figure. You have the a similar kind of figure, but it will be smaller than the isometric view figure. So the isometric view figure is slightly enlarged than the isometric projection figure. Now to sum it up, what is the next step? You find out the center of the top surface, which is this surface. What is the height that you take to locate the center of the sphere? Is it 10 mm? No, it's not 10 mm. It is 10 times 10 into 0.816, or the isometric length of 10 mm. So we have found out this here. Take that distance, offset it here. That's your center. Now, the important thing. So to locate the center of the sphere up to that point, we have followed the same procedure. Every time you take a dimension, you multiply by 0.816, or you find out the corresponding isometric length from the isometric scale. But when you draw the circle, the radius of the circle is the actual radius. All right. To point out precisely, locate the center of the top surface of the square slab. Take the height as 10 into 0.816, which is 8.16 millimeters. To locate the center of the sphere, you offset a distance 8.16, but when you draw the circle, the radius of the circle is 10 mm. So each time when have you noticed something? Each time up to the point where you locate the center of the sphere, you can follow the same pattern, but when you draw the circle, you have to draw it at a enlarged radius. The radius of the circle will be more than that you have taken to locate the center. In this case, you have taken 8.16 to locate the center. The radius is more than 8.16, 10 mm. In this case, you've taken 10 mm to locate the center of the sphere, but when you draw the circle, the radius is 12.22, more than 10. So this is the way you can remember it. So I have finished up to this point. You can see it. I have considered an isometric scale. Now, each time to demonstrate, this is 40 mm distance. I've drawn an isometric projection first. Taken 40 mm distance, offset at this side, parallel to this edge. I've drawn this line. So that is my isometric length corresponding to 40 mm. Taken that distance, offset it here, constructed the square. Then taken 10 mm distance, the thickness, offset it here, correspondingly find out the isometric length, offset that distance, and complete the square. Now I'll locate the center point by drawing the diagonal of the top surface, center point right here. I have to find out the center of the circle, center of the sphere, taken 10 mm distance, the corresponding isometric length, taken the corresponding isometric length, offset it here, found out the center of the circle. See, each time I take a dimension, I make sure that it is the corresponding isometric length I have offset it here. Now to draw the final circle, what is the dimension that I have taken? In the case of isometric projection, I have to take the actual radius, which is 10 mm. Actual radius given in the question. So take this actual radius and then draw the circle. Right? Now finish it off like this. So that is the isometric projection of that thing. Isometric view, actually, to draw the isometric view, we actually take the actual dimensions. See, 40 mm, 40 mm. So you can compare these two figures. This is slightly enlarged than this figure. To locate the center of this, you draw the diagonal. This is the center of the top surface of the square slab. Take 10 mm, 10 mm from the center portion of this slab. The height of this is 10 mm. Take the 10 mm distance. Now, what is the radius of the circle? It is 1.22 times the actual radius. So I'm going to take 12 mm. Then the center, this is radius. Right. As you can see this. Right. So that completes. This is the isometric view. So what is the difference? The difference is this. This consists of the actual radius or 10. Radius is 10. Here the radius of the circle is or 12.2. That is 1.22 times 1.22 times the actual radius. Here projection, for projection you have the actual radius. That is the difference, right? I want you to try the isometric projection and isometric view also. The reason I have given you this question is to show you the difference when you draw the isometric projection of a sphere and the isometric projection of a isometric view of a sphere and isometric projection of a sphere. In the case of projection, this radius of the circle is actual radius. In the case of view, the radius of the circle is 1.22 times the actual radius. That's it.